look at how Grasshopper processes and maintains parallel lists. And we're going to do that by creating a series of boxes and then sorting them. So very exciting. So the first thing to do is to create a series of boxes. We're going to create a series of random boxes. So we're bringing the random component and we'll just create like 10 or 12 boxes, and then the other element is the seed, because these numbers are not actually random, they're just generated to look like they're random. So, but we'll see that in a minute. And you just want to construct a domain which is a top and bottom top and bottom limit for the random numbers. So I'm going to do 255 because we're going to use this as a size of the box, but also the color. So we should be already getting numbers here. I'll just use this one again. We don't really need this one, but looks tidy. So I'm just going to put some notes in as well. And I'm going to make this into a group by choosing Command or Control G. So this is creating a list of 12 numbers, and they're all random, or kind of random. We're going to use that list to create a box, a series of boxes. So the box that we're going to use is the 2-point box. We need a bottom corner and a top corner for each of these. So we're going to use the random number list to create a series of points. So we're just going to construct a point, and we're just going to use all three XYZs are going to be the same. And on the side in the Rhino window you can see those points appearing. So we need a top point which will just keep as 0, 0. So that's that one. And then the bottom point is the random number. So we'll get a series of boxes that are all inside each other. Currently they're just inside of each other. So we'll put a note in here. Random box list. So we've used a random number list to create a random box list. So what I want to do is make a little way of viewing those, and we're going to use a little thing called mass addition, which just adds a list up. So we're going to add up the centroid, the central thing for each box. So that's inside of volume. So this component calculates the volume of each box, and it also calculates the centroid of each box, and that's the center point. So we're going to use that to position the boxes in a line. So we use that center point, we add all the center points together, and then we use that to move each box like this. So they should all go in a line. So they're all now arranged in a line. We'll just turn off this one. We'll turn off these ones as well. Volume, we don't want these. So what we're seeing is a list of boxes, but they are all intersecting each other from the center points, and they also don't start at the origin, which is 0, 0, 0. So the reason that they don't start at the origin is because this list is partial. It's a partial results list, so that actually it's only missing one thing, which is the beginning. So we have to insert that item. I'm sure there's a few ways of doing this, but we're going to insert an item which is 0, 0, 0. So we put the list in here, and then the item that we want, we're going to have to type that manually. We could create a point of 0, 0, but we'll just for a change, we'll type it. So that's a manual point, which goes to this one, that's the item. The insert point is going to be 0. Don't worry about the wrap. So you can see that we've now, I've got this the wrong way around. Oh, made a mistake, wrong way around. Okay, so I've added a point there, a 0 origin point at the beginning of this list, and we should hopefully see this now shift down. So, okay, so you can see that the centroids are now in the middle of each cube, and the list starts at the beginning. But also, it would be better if it went from corner to corner, and that's easy enough, because we could just add the centroids together. So we just have an addition, and then we just add them together, and that should move them all apart like that. So let's just turn off these previews, and we've got another set of points there. So there you go, we've got a random list of cubes. So that's not the point that I'm trying to show you. But it's a step in the right direction. What's the note? So let's just make a note on this before we forget. Mass addition of the centroids for moving we can just add, wait a minute, let's add colour to this. Just get rid of that, we don't need that anymore. So we can use the size of the box to create a colour. So we could do the small boxes would be dark, and the large boxes are going to be lighter coloured. So we do it with an RGB component, and then we can just connect that to a couple of these. If we do all three, it'll just be a grey. So that's given us a series of colours, and then we'll just use that as a preview, custom preview. So the geometry goes into there. You can turn that off now. And then the colour comes from here. So we should get dark boxes. The small boxes are dark, but the big ones are light. So that's what we're seeing. And if we go back here, we can change the random generator, the seed, and we can change the number. So we can go down and add or take away. So there you go. So what we want to do to demonstrate how Grasshopper maintains lists, we want to sort these into different, want to sort these in terms of size, and that component is called sort. So what we do is we connect, we need this volume, and so we're going to sort in terms of volume. So we just connected volume to the top level of the key of sort, and now we should get out of here, it should be in order, which is, it was a bit hard to see that, but that's now in order. But the sort has just produced, it hasn't produced anything apart from a list of volume, but we're not using that anyway in any of these other things. So what we have to do is use that sort as a way of sorting everything. So we can zoom into sort and we can add how many channels we want to sort, and I know that we're going to use 3. So one of them is going to be the centroid, so that goes into there, and I think it'd be good if we just copied this whole thing. So we select all and copy, so move that down here, and we now want to replace the centroid here, and the geometry stays the same. We need another preview, so just copy that for now, but then we just switch this over. So I'm not quite sure what point we're at, but we can turn this one off and we can see what we've got. So we've got a bit of a mess. We need to sort some other things. So we actually need to sort at the same time. So you can see that it's sorting by volume, and it's sorting, using that to sort the centroids, but we're not sorting the geometry. So it's now confused because it's using the original geometry list, but the old centroid, the old centers, and so that's why we're getting a mess. So if we need to sort at the same time the geometry, and we need to pass that on to the move, the repositioning thing. So now we've done that, we can see that we've got a correct list, and as you can see, it's going from the small to the big. So, but the colours, again, the colours have not been sorted. They're just coming straight from the original list, so they're all wrong. So we sort the colours again, and we put those through there, and you should now get a list. So you can see the small cubes are dark, the large cubes are light, and they've all been sorted at the same time. And you can see from, as we're connecting it up incorrectly, that if you don't maintain these lists correctly, then you're going to get, well, in this example, you're going to get something that you didn't want. In another example, you might actually want to switch up the lists. And we've seen that in quite a few things where you have an original list, you branch off one piece of the data, maybe the Z, and you do something to that, and then you bring it back together again. So let's just put a quick note in here. This is before sorting. this is after sorting. And I suppose we could do a little note here so we can remember what this is. This is a volume sort, volume list sort with parallel sorts. We don't really need to say what they are. Just call this colour by size so we remember that's what we're doing. So just to recap, we create a list of random numbers between 0 and 255. We use that to create a random box list. We also use that to create some colours. We then sort that random box list by the volume, so we get a list from the smallest to the biggest, and then we use that list. We use that sort to sort everything else at the same time, and then we pass that across to this where we use mass addition, double it up, insert a origin point, and use that list to move all the boxes so they touch point to point and create a kind of column in order of size.